Hello, welcome to Maths class once again. My name is Jimmy Gabriel. Today we'll be looking at angles again. Last time we checked angle, how to measure angle, how to construct angle. But before we go into angles again today, here is a correction to the last assignment. Find the angle between the hour hand and the minute hand at 4 o'clock, 6 o'clock, 9 o'clock, and 10 o'clock. At 4 o'clock, it is like this. So that means you have to get the revolution first, which is 4 all over 12. Out of 12, we have in one revolution. At 4 o'clock, the hour hand has covered only 4 of the fraction of 12. Now, our revolution is 4 over 12. You then convert the revolution to angle by multiplying it with 360 degrees. 4 over 12 times 360, 12 here 1, 12 here 30. 30 times 4 will give us 120. At 6 o'clock, the revolution is 6 over 12. Then convert it to angle by multiplying it with 360 degrees. That is 6 over 12 times 360. 12 in 360, we have 30. 6 times 30, our answer is 180 degrees. The same thing at 9 o'clock, the revolution is 9 over 12. Then you convert it to angle by multiplying it again with 360. You have 270 degrees. At 10 o'clock, the revolution is 10 all over 12. Then 10 over 12 times 360 degrees. That is 12 here 1, 12 here 30. 10 times 30, you have 300 degrees. That is the solution to last assignment. Then, before we move straight, here are the objectives of this angle. Now, at the end of this topic, you should be able to calculate the size of angles between lines using property of adjacent angle, vertically opposite angles, and angles at a point. 2. Calculate the size of angles between parallel lines and transversal line using the property of alternate angle and corresponding angle. And lastly, use the sum of angles in a triangle to find the unknown angles in a triangle. Now, the first property we'll be looking at is adjacent angles. Now, when two angles lie beside each other and have a common vertex, they are adjacent to each other. Now, look at this now. We have line OA and line OC. In between, we have line OB. Now, O is the common vertex that they share, that they have in common. AOB is adjacent to BOC. BOC is adjacent to BOA. That is adjacent angles. Now we move to when a straight line stands on another straight line, two adjacent angles are formed. When a straight line stands on another straight line, two adjacent angles are formed. Now the sum of the two adjacent angle is 180. Now look at this is a straight line. Now another line is joining it. It could be from anywhere. You could have it as this, it stays the same thing. You could have it as this, it stays the same thing. You can see when one line join, we have two adjacent angles. One is this, another one is this. We have BOC and COA. That is, this angle here, let's say it is X degree, and the angle here is Y degree. By the time you sum up the two together, it should give you 180 degree. That is a law or rule. That is, the sum of angle on its the sum of the two adjacent angle is 180 degree. That is, when you add this angle, that is BOC is X, and C, you can call it COA or AOC. Why? The sum of which will give you 180 degree. Now, we move to vertically opposite angles. Vertically opposite angle, you can see, just like in case of your plier or scissors, it crosses like this. Now, when two straight lines intersect, like the one I just drew, 4 angles are formed. How many angles? 4 angles are formed. The two angles opposite each other are called vertically opposite. Now, what do I mean? Look at, when two lines crosses or intersect, the angle here and the angle here, we call them vertically opposite angle. That is, whatever you have here, let's say this angle is 80 degree. This side too will also be 80 degree. We say AOD equals to BOC. Now, also, whatever here, you can see this place too, they are also vertically opposite. If this place is, let's say, 50 degree, here too will also be 50 degree. That is, vertically opposite angle are always equal. You can see here, angle AOD equals to angle BOC. Angle AOC, you can see this is AOC, equals to BOD. Now, this is BOC, you can see, and this is AOD. That is, vertically opposite angle are always equal. Now, angle meeting at a point. You can have different angles meeting at a point. This is the point at which these angles are meeting. These lines are meeting. Now, when two or more lines meet at a point, they will form the same number. They will form the same numbers of angle. When two or more lines meet at a point, they will form the same number of angles. For instance, look at this. We have 1, 2, 3, 4, 5. 5 lines meeting at point O. If you count, they form the same number of angles. 1, 2, 3, 4, 5. Now, the sum of the angle at this point equals to 360. By the time you can see from what I just marked there, they have formed a circle indirectly. That means angle AOB, this is AOB, BOC, then COD, and DOE, and AOE equals to 360 degrees. That is, when you have angles at a point, the sum of those angles equals to 360 degrees. You might have 3 lines meeting at a point, depending, but whatever angles you have at a point, by the time you sum up them together, you have 360 degrees. You will see all this I'm talking about by the time we start taking examples. Now, calculating the sizes of angles. Now, the first one is, look at this example. AOB and COD are straight line that meet at point O. This is AOCD, AOB, and COD. Find the angles AOC and AOD. Now, we have many properties on these angles that we have here. Number one, we have vertically opposite angle. AOB is a straight line. OD is joining it if I'm considering only the upper part of AOB. Now, look at, that means AOC is also equals to what? 53 degrees. The reason is vertically opposite to BOD. That is the reason why this place will also be 53 degrees. You can see it here. Is what? 53 degrees. Now, to find AOD, look at AOD, we can consider it as two adjacent angles. Look at, and we know that sum of angle, the sum of two adjacent angle on a straight line, AOB, equals to 180. That is, the angle here, AOD plus BOD equals to 180 degrees. And what is our AOD? We don't know it. So we know BOD to be 53. Now, to get AOD, you subtract 53 from 180, which is what I've done here, to get 127 degrees. You can see it's not hard. Now, look at this place. AOD is vertically opposite to what? BOC. Now, if here is 127, here also will be 127 degrees. That is that on that example. Example 2. We have to calculate other angles that we have here. Now, like I said, this is a straight line. This line is joining it. I can find AOD using the property of two adjacent angles on a straight line. Like we know that the sum of two adjacent angles on a straight line equals to 180 degrees. But you can see also again where these two lines crosses, BOD is vertically opposite AOC. You can see AOC. The middle point is called O. So O is common to all the lines and the angles. You can see we have it here. The reason is why AOC equals to 62 degrees as BOD is because AOC is vertically opposite BOD. Now we can find AOD using this like we have before. AOD equals to 180 minus 62 degrees. You know, let me put X here. If I add X plus 62 equals to 180. Now, X equals to 180 minus 62. That is why we have it as 118 degrees. Look at. Now, we can now find COE. We can find our COE with some. Now, we find COE from angle at a point. BOE is 77 degree. It was omitted. BOE is 77 degree. Now, to find COE, we now use angle meeting at a point. COE equals to 360 minus 62 plus 118 plus 62 plus 77. The reason is sum of angle at O. Now, by the time you subtract, your COE equals to 41 degree. COE equals to 41 degree. Don't forget, you can also use other property to get it, but the straightforward one is calculating everything, because we have here, we have this point, we have here, we have here. Only this part is missing. We can then use angle at a point. You can also use a straight line. You can see this is straight, this is one angle, this is one, and this is one. That means you'll be considering only COD. But to make your work easier, you can use angle at a point. But when studying alone, you can try what I've just mentioned. Now, calculate the size of the letter. Now, look at, we have just two, we have a line that meets this line AB at this point. Let's say this is point O. This is the reason. Adjacent angle on straight line AB. Now, the angle here, we know that the sum of two adjacent angles on a straight line is 180. Now, 98 plus x equals to 180. X equals to 180 minus 98 equals to 82 degrees, sorry. That is how to calculate the size, or the size of the letter representing an angle. Now, find the size of the letter X. Look at, this is a straight line. We have how many adjacent angles? 1, 2, 3, 4. You can see. Now, we know that angle on a straight line, you sum up all those angles together to equals to 180. Now, x plus 40 plus x plus 60 equals to 180. Now, rearrange it. X plus 40 plus 60 plus 180. X plus x equals to 2x. 40 plus 60 equals to 100. Now, rearrange. Collect like times together. That will be 2x equals to 180 minus 100. 2x equals to 80. By the time you subtract, now x equals to 40 degree. That is how to find the size of the letter X in this particular angles on straight line. Now, find the value of X. You can see this one, only this side and this side are equal. You can see here is 100, here is 130. This one and this one, they are not equal. So we can say these two, they are vertically opposite. But we can use the property of angles meeting at a point to solve for X. Now, what do we do? X plus 100 plus x plus 130 equals to 60, because they are meeting at a point. Now, rearrange again. We have x plus 100 plus 130. Now, x plus x equals to 2x. 100 plus 130 will give you 230 equals to 360 degree. Now, collect like times together. 2x equals to 360 minus 230 degree. Now, which will give us 130. Now, divide both sides by 2. X is equals to 130 divided by 2 equals to 65 degree. Now, we move to parallel lines. Parallel lines are lines that never meet at any point. Look at these two lines. They are said to be parallel. Even if you produce them backward, they will never meet. So long as they are parallel, we call them parallel lines. They can never meet at any point. While non-parallel lines will intersect if they are produced or extended. Look at this line. If I produce it backward and this one too backward, you can see they intersected. So this one we call them non-parallel lines. Now, we have alternate angles and corresponding angles. Now, when you have two parallel lines, you have a pair of lines, a line crossing it at the middle. Now, all these lines that are yellow, we call them alternate angle. You can see the one that have the same color. We call them alternate angle. This line crossing it is called transversal line. It's called what? Transversal line. You can see, you can check all the colors. Where you have the same color, it means they are alternate, just like opposite. You can see this place, this color and this color. You can see this color. It means they are alternate, just like when one is facing down, the other one is facing up. You can see that. That is alternate angle. Check them by the color. You will see that they are alternate. They are facing oppositely. When one is facing this side, another one is facing this side. Look at this blue color. When it's facing this side, this one is facing this side. Alternate means like opposite of the first one. Look at this. This one is facing here, while this one is facing this side. We call them alternate angle. While this is facing this side, this one is facing this side. They are all examples of alternate angle. Now we move to corresponding angles. Corresponding angles. That means they are all facing the same side. Look at. Check the color. They are all facing the same direction. Look at. All those ones facing the same direction, we call them corresponding angle. Just like saying when they are in the same direction or they are facing the same direction. One is corresponding angle, while this one is alternate angles. Now, example. 70, you can see we have different properties here. We have angle meeting at a point, like this middle point. Then we have vertically opposite angles. Then we have angle on a straight line. Then we have corresponding angles. You can see that is A is corresponding to D. Then we also have alternate angles like this place and this place. That is 70 is also alternate to E. You can use this one to find the values of A, B, C, D, E, F. For instance, B equals to 70 degrees. You state your reason there. Vertically opposite angles. Now look at E equals to 70 degrees. Reason is that they are alternate angle. Sorry, I can't write everything full. Now look at when you have E. E is also equals to G, which is also equals to 70. Reason is that they are vertically opposite angle. Look at. They are vertically opposite angles. Look at. We have B. B is also corresponding to E, which is also the same thing. That means B also is what? 70 degrees. Now, when we have our E, how do we get our D? They are all the same thing. It's just that reason we differentiate them. One is corresponding, one is alternate, one is vertically opposite angle. Every other one is also 70 degrees. Now, I will give you as an assignment, which you will post to me later, the value of A, C, D, and F with reasons. Now, angle in a triangle. Now, look at, this is a parallel lines. these two, they are parallel. Now, the angle here is y degree, the angle here is z degree, x degree, and the angle here is z degree. You can form a triangle from there. That is, we can also formulate an angle from there to calculate the sizes of this triangle in this figure. Now, you can see this place and this place, they are alternate. That is why we have inside of this angle to be what? Y degree. X, this side and this side, they are also alternate. Now, from our knowledge of sum of angle on a straight line, we now consider this place as a straight line angle. Now, x plus z plus y equals to 180 degrees. Now, that means all this value, when you sum them together, you have x plus y plus z equals to 180 degrees. Now, the sum of angle in a triangle equals to, thus, the sum of angle in a triangle, any triangle, is 180 degrees. That is, you sum this angle with this angle to this angle, it must give you 180 degrees. Now, to find any missing angle in a triangle, you sum the two other sides given, then subtract it from 180, it will give you the third angle that is missing. Now, look at this example. When you have this line, it means this angle and this angle, they are equal. That is the meaning of this line. That means E is also equals to 75 degrees. E is also equals to 75 degrees. Now, we can now find F. And we know that the sum of angle in a triangle is 180. That is, sum of angle in a triangle is 180 degrees. You know, we said x plus y plus z equals to 180. Now, but in this case, we are not using x, y, z. We are using f. That will be f plus 75 plus e equals to 180. Now, we know that E is equals to F. E is also equal to 75. That will be E plus 75 plus 75 equals to 180. These two, when you sum, it will give you 150. F plus 150 equals to 180. F equals to 180 minus 150 equals to 30 degrees. That is the value of F. Another example is this. This is a straight line, and we know sum of angle on a straight line is also 180. That means U equals to 180 minus 65. 180 minus 65, that will be equals to 180 minus 55. U equals to 115 degree. Now, you have gotten U. That means our V can also be 180 minus 25 plus 115. 25 minus 115. Now, 180 minus 140. When you add 25 and 15, 150, it will give us 140. Now, our V equals to 40 degree. The same way, you just look for which one that are alternate to each other. You find the other angles. There's no space for me to calculate all this one again, but I will just explain. I can also be given as an assignment. Now you can see this place and this place, they are alternate. That means here is also 25. Here is alternate. That means here is also 40 degree, because this place is 40 degree. Now, when you add 40 to 25 to be 65, when you subtract from 180, you have 115 degree. Now, assignment. You have to calculate the sizes of the letters angle and give reasons. Also this, and this is the summary of what we just did. For further reading, consult your new General Mathematics, GS1, page 159 to 169. But let's quickly go back to what we have here. Look at this angle and this angle, they are alternate. That is why I put 25 here. This angle and this angle, they are also alternate. That's why I put 40 here. When you add them together, it will be 65. You can see this side is alternate to this side all together. Till I come your way next time. But the summary, this is the summary telling you that the sum of adjacent angle on a straight line is 180 degrees. That is, when you have two angles on a straight line, that is x plus y equals to 180. If you have three angles, it will be x plus y plus z equals to 180. Vertically opposite angles are equal. The sum of angles at a point is 360 degrees. A transversal line is a line that cuts a pair of parallel and non-parallel lines. Till I come your way again next time, have a wonderful day.